What is the smallest thing? This was a question originally proposed by Democritus, yes, this friggin' guy, in 400 BCE. Democritus coined the term atomos, or atom, which is Greek for indivisible. He believed that atoms were solid, uniform, and indestructible particles that made up everything in existence. He was wrong on all of these counts, but he was actually shockingly close considering he made these predictions so long ago. It's often considered the best guess in antiquity, and for good reason. He believed that different forms of matter could be described by their arrangement of atoms, liquids having slippery atoms and solids were more stuck together. He also believed weight and density were due to the distance between atoms, and materials with more atoms weighed more. The only problem with his theory was that he had absolutely no evidence whatsoever, and so it was largely mocked and ridiculed. It wouldn't be until 2,000 years later that anyone would start to give his theory some credit. 1803. Yes, that's correct. Isaac Newton did not know atoms existed. John Dalton, an English chemist from Manchester, was studying gases and pressure when he realized that during chemical reactions, different materials would combine in specific ratios, which violated conservation of mass. He proposed that there were different forms of atoms, and they could combine with each other to form specific combinations. He was much closer than Democritus, but still off on several accounts. I mean, soda? Really? Soda is comprised of like 3 different elements. Either way, he still had little to no evidence of atoms' existence. He knew there were different types of particles, but he never actually observed them. His only clue to their existence was by quantitative experimentation. It wouldn't be until 1827 that Robert Brown would observe pollen moving randomly on still water through a microscope and coin the term Brownian Motion to describe the phenomenon, effectively cementing the existence of atoms in the scientific community. But we can go even smaller. In 1897, J.J. Thomson made a shocking discovery when he fired a cathode ray and realized that it traveled much further than expected for a hydrogen-sized particle. He came to the conclusion that atoms were made of even smaller particles that were over 1,000 times lighter than the hydrogen atom, and named them corpuscles, which was a really stupid name, and it was later renamed to electrons, which you've heard of. He proposed a new atomic model where the corpuscles, or electrons, sat in a giant ball or soup of positive matter, kind of like a really cursed watermelon, or as he called it, the Plum pudding model. Yeah, J.J. Thomson was an interesting guy. Ernest Rutherford would disprove the Plum pudding model in 1919 when he discovered the proton by shooting alpha particles at a gold foil. The chaotic motion of these particles proved that they had a positive charge and repelled each other when shot through the gold foil. He would create the Rutherfordian model, where electrons orbit around a positively charged nucleus, like planets orbiting the sun. While this model is still often taught to this day, and it's a good approximation of the atom, it's not entirely accurate. There's one problem with this model. How do the neutrons and protons stick together? Protons are positively charged, and neutrons have no charge, so if anything, shouldn't they have an, albeit minor, repulsion? Murray Gell-Mann would coin the term quark in 1964, although George Zweig also independently formulated this theory at the same time. Protons and neutrons are made up of quarks, and their composition describes their different charges and mass. They're bonded via the strong nuclear force, which is way too complicated and deserves a video of its own, but all you need to know is that it's very powerful at short distances and counterbalances the static repulsion from the electromagnetic force. Meet the Standard Model. This is our best guess as to what the fundamental particles of the universe are. Quarks, leptons, and bosons make up everything in the known universe, and we finally have the answer to what is the smallest thing. It's the Standard Model of particles. Or is it? A recent theory has shaken the core fundamentals of particle physics and is a solution to several problems proposed by our current model. String theory. String theory imagines every particle as an infinitesimal string, which vibrates at a certain frequency. The frequency of this vibration determines the type of particle. Oh, but it gets much more complicated than that. Theorists suggest that these strings are multidimensional, and depending on your model, they can inhabit up to 26 different spatial dimensions. 26. So what actual proof is there for string theory? None. It checks out in mathematics, which is why physicists like it, and there's no undeniable proof it's not true, so there's that. But no observable evidence has been brought forward whatsoever. But hey, Democritus didn't have any evidence either, and he turned out to be mostly correct. And who knows, there's probably something even smaller than string theory. If history has taught us anything, it's that you can always go smaller. As always, if you enjoyed this video, make sure to leave a like and subscribe, as it helps out a ton. If you have any suggestions for future videos, leave one down in the comments. See you in the next one.